If you have any questions, just type them. Oh, wait, let's check. I'm sorry. Okay, so let me start. So if you have any questions, just type them into the text box. So last time we were starting section 5.2, polynomials. So an example of a polynomial would be something like 3x to the 4 minus 12x cubed plus 9x minus 19. A polynomial consists of a whole bunch of terms. So each of these are terms. Hmm. Each term let me just check. Okay, let me make the I'll make that a little thicker. Okay, so each term, actually I can, let's do this. See if I can do this. Maybe it won't. Okay, I didn't make this one thicker, but maybe the other one's thicker. Okay, forget that. Okay, so, um, is it? Oh well, I'll just, hopefully now I'll make it bigger. Okay, so 9, there, x cubed. So 9x cubed consists of, well, so that's a term, and it consists of two parts. The variable part, and the numerical coefficient. And so we usually just say the term coefficient. And the variable part consists of a variable to some whole number exponent. Okay? And so, in general, a polynomial of in one variable, let's say, um, in the variable x. We'll have the form. Well, it'll just be a whole bunch of terms. Maybe I'll say some constant times x to a power plus another constant times x to another power plus, well, a whole bunch of these until we just have a constant term. So this is where a0, a1, up to an, these are real numbers. And where n is a whole number. If the leading order coefficient is not 0, then n is called the degree of the polynomial. So let's do an example. Well, let's say the polynomial p is 2x to the 4 minus 3x plus 13. Then the degree of this polynomial, I'll call it p, is 4. Because the exponent, the highest exponent, is 4 in this polynomial. So in general, the degree of a term let's say if I had 14x cubed y squared. So suppose I have more than one variable, then the degree of this term is just the sum of all the exponents of all my variables. So in this case, 3 and 2. And so the degree of this particular term is 5. Now, the degree of a polynomial is just the maximum degree of any term in the polynomial. So let's do an example. Let's say I had 18x squared plus 14xy cubed minus 23x squared y. Then let's look at the degree of each of the terms. So then the degree of 18x squared, well, there's only one variable, so the degree in this case will be its exponent, 2. The degree of the next term, 14xy cubed, is just going to be, well, the degree of the term x is 1. The degree of the variable y is 3. 1 plus 3 is 4. The degree of the term 23x squared y, well, the exponent of x is 2. The exponent of y is 1. 2 plus 1 is 3. Therefore, the largest of the numbers 2, 4, and 3 is 4. And so the degree of my polynomial is 4. Okay. Let me give you some terminology. And so a monomial is a polynomial that consists of one term, such as, let's say, if I just wrote 14x cubed, that would be a monomial. A binomial is one that consists of two terms. And so if I just said 18x squared plus 14xy cubed, that would be a binomial. A trinomial is one that consists of three terms. So 18x squared plus 14xy cubed minus 23x squared y, that would be considered a trinomial. In general, that's anything that has more terms. We don't really give it any sort of special name. So we give names to particular terms. The constant term, well, let's do this. Um, a constant polynomial is one that has degree 0. A linear polynomial is one that has degree 1. A quadratic polynomial is one that has degree 2. A cubic polynomial is one that has degree 3. A quartic polynomial is one that has degree 4. We have etc. But I'll sort of leave it at that. Um, in this polynomial here, well, maybe I'll say it in general. So the constant term is the term with no variable. So in the above case, it was that A0 term. The linear term was a term with the variable and so in the above it was A1x. The quadratic term was the term with the variable squared. So in the above it was A2x squared. The cubic term is a term with the variable cubed. So in the above case, it was the sub 3x cubed. I went to quartic. So the quartic term is the term with the variable to the fourth power. So in the above case, it was a to the 4x to the 4, etc. The constant coefficient, well, usually just the constant, is, well, the same as the constant term. The linear coefficient let me not do those. Well, I'll just say it'll be obvious when I say those, so I'm not going to write those down. The leading order coefficient is the coefficient of the term with the largest degree. And we denote this by leading order coefficient. A monic polynomial is a polynomial where the leading order coefficient is 1. And so there it is. There. So the term 13 has no variable in it. It's just a number. So that's the constant term. That's and so if I was asking you for the constant term in this polynomial, that would be its constant term. Okay. Okay. So let's do some examples. Yeah, so for right now, this is all just sort of a lot of terminology. So let's do on, see, page 190. In exercises 1 through 10, identify the algebraic expressions which are polynomials. So I want to determine which of these are polynomials. So let's do problem number 2. Negative 3 x cubed plus 5x minus x. So I've got to check, is this a sum of a whole bunch of terms? And are each of these terms variable to whole number exponents? And so I don't want any variable to a power that's other than a whole number. So no negatives, no fractions, nothing of that sort. And so x cubed, yeah, that's a whole number, exponent. X to the first, so it's just x. So yes, that's fine. This is just x. So yes, this is a polynomial in the variable x. Let's do problem number 6. 3x, 3y squared minus 1 over y plus 2y plus 6. Okay, so let's see if this is a polynomial. Well, I have here 3y squared, so that's a fine term. But then I have minus 1 over y. So, no. The 1 over y, that makes it not a polynomial. So this is, I can't have that. And so, no, this is not a polynomial. Because you cannot have variables in a denominator. That no, because right, because the because it's 1 over y, so you cannot have a y in the denominator. Let me do problem number 10. X cubed over 3 minus 4x squared minus 7. And so I have an x, and it's to a whole number exponent 3. I have an x, and it's to the whole number exponent 2. And I have, well, a constant term. So each of these terms are nice polynomial terms, and I'm just adding them. Well, adding and subtracting them. So therefore, yes, this is a polynomial in X. So notice that it's not, you cannot have a variable in the denominator, but it's okay to have constants in denominators. That's perfectly fine. Let me do problem number 12. And so in exercises 11 through 18, write the polynomial in descending order of powers of the variable. Also find the degree and the constant term in each case. And so I have here 3 plus 2 z to the 6 plus, plus 3 z squared minus z to the 4th. Okay, so I want to write this polynomial in descending order. So I'm going to look for the term that has the highest degree. So in this case, if I look here, well, the highest degree of my variable is to the power 6. And so I should write that term first. So I'm going to write the term 2z to the 6 first. Next, I look and I have a z to the 4th, and that's larger than any of the other degrees, so I'll write that second. Next, I just have a 3z squared, and that's larger, has a larger exponent than the constant term. So I'll write that next, 3z squared. And then lastly, I just have the constant term 3. And that is my polynomial written in descending order. So we usually like to write polynomials in descending order when we start from the highest, the term with highest degree and go down to the term with lowest degree. The degree of this polynomial, well, the degree of the largest power is as one variable, so I just look at the powers. The largest power for the variable is 6. Therefore, the degree of this polynomial is 6. The constant term, the term that doesn't have the variable, is 3. Let me do problem number 16. Six minus x to the 6 plus x to the 4 plus x to the 8 plus 2x to the 5th. So let's write this in descending order. Well, the term that this only has one variable, so let's look at the highest powers of the variable. Highest power of the variable is 8, so let's write that first. The next highest power is 6, so let's write minus x to the 6. The next highest power is 5, so let's write 2x to the 5th. The next highest power is 4, so let's write x to the 4th. And then we have the constant term 6. I've written my polynomial in descending order. The degree of this polynomial, the highest power is 8. So the degree of my polynomial is 8. The constant term, well, the term without any variable is 6. And that is your answer. Notice, in this case, this is an example of a monic polynomial, because the coefficient, the number in front of the term that has highest degree is 1. So notice that there's just no, there's no number in front of this variable that has highest degree. Therefore, this is called a monic polynomial. Okay, let me do problem number 20. In exercises 19 through 30, identify which is a monomial, binomial, trinomial, or any of the other types of polynomials. What is the degree of the polynomial? So I have here 1 minus 2x plus 3x cubed. Why monic? So remember, monic, let's go back to here. A monic polynomial is one where the leading order coefficient is 1, meaning I look at the number in front of the highest term. The number in front of the highest term is 1, therefore it's monic. This is not monic because the number in front of the highest term is 2. This is not monic because the highest number in the leading order coefficient is 1/3. So if this is not monic because the leading order coefficient is 3. Let's see. Did I have any other monics? No, those had numbers in front of them. So if the term, if I had something like x cubed minus 4x plus 7, then this would be monic because the number in front of the highest term, the leading order coefficient, would be 1. So that's a monic polynomial. So in this case above, it's monic because the number in front of the leading order coefficient is just 1. Okay. So I want to identify if this is a monomial, binomial, trinomial, etc. Ooh, no, monic is not a monomial. Aha. No, monic, those are completely different terms. Monic means there's a, I see, because they both start with mon. Monic means there's a 1 in the leading order term. There's a 1 in front of the, there's no think of it, a monic means there's no constant in front of the variable. It's just the variable to a power. That's the highest term. A monomial means there's only one term. It's just one entity. Okay, so for monomials, binomials, we're counting the number of terms. In a monic, I'm just seeing is the number in front of the highest term 1. Okay, so those are completely different terms. So let's count the number of terms. Okay, so if I count the number of terms as 1, 2, 3 terms, therefore this is a trinomial. Because there are 1, 2, 3 terms. The degree of this polynomial, well, I look at the highest power. The highest power in this case is 3. Let's do problem number 22. The polynomial is 5. Well, this is an example of a monomial. It's not a monic polynomial because the leading order coefficient is 5, not 1. So it's a monomial. Notice that the degree of my polynomial, well, I want the variable to a power. There is none. Therefore, I say that the degree of this polynomial is 0. I guess note this is not a monic polynomial. So it's a monomial, but it's not a monic polynomial. Let's do problem number 30. One minus 2x plus 4x squared minus x cubed. So this is the same as 1 minus 2x plus 4x squared minus x cubed. Let's write this in descending order. So negative x cubed plus 4x squared minus 2x plus 1. So the degree of this polynomial is 3. There are 1, 2, 3, 4 terms. Well, if there's one term, it's a monomial, 2, binomial, 3, trinomial, 4. We don't really have a special name for it, so I'll just call it a polynomial in general. Of course, all the other ones are also polynomials, but we just don't have a special name for this polynomial. So I'll just say It's a polynomial. Okay. Let me do problem number, let's say 32, I guess. In exercises 31 through 38, evaluate the polynomial when x is 2 and when x is negative 2. So first, let's look at 7x plus 3x cubed minus 5x to the 4. So first, I want to evaluate when x equals 2. So let's do that. So let's substitute for x, 2. So wherever I see an x in the equation, I'll replace x by 2. X in the expression, I'll replace x by 2. And it is a good habit to, whenever I see an x whenever I do a replacement, I should put a parentheses around what I replace. And so let's do that. 7 times 2 is 14. 2 cubed is 8. 2 to the 4th is 16. 3 times 8 is 24. 5 times 16 is 80. 14 plus 24 is 38. Minus 80 is a negative 42. Let me do part 2. So let x equal negative 2. So wherever I see x, I replace x by negative 2. So since I'm in a habit, I will put a parentheses around it. In this case, it actually makes a very big difference. And so put a parentheses around the negative 2. Seven times negative 2 is negative 14. Negative 2 cubed is negative 8. Oops. Negative 2 to the 4th is 16. Negative 8 times negative 8 is negative 6. Oops, how did I put a 3 times negative 8 is a negative 24. 5 times 16 is 80. Negative 14 minus 80. Well, negative 14 minus 24 is a negative 38. Minus 80 is negative 118. Let me do problem number 40. In exercises 39 through 50, add the polynomials. Okay, so I want to add x to the 4 minus 3x squared plus 5. I guess and I want to add that to another polynomial. I guess what I'm going to do here is I'm just going to put one polynomial under the other polynomial to add them. And when I do that, I'll try to line up corresponding terms so I can add like terms. So let me put the 2x squared underneath the 3x squared, and let me put the minus 4 under the 5. And so if I do that, then I can add these easily. So I get x to the 4th 2x squared minus 3x squared is minus x squared. 5 minus 4 is 1. And so if I line these up where I put like terms underneath each other, I can add these up easily. Okay, so notice that I have here 2x squared. It is a like term to 3x squared. The x squares are identical. And I have here a minus 4 and 5. And notice that neither of those have variables. And so I can just add it. 5 minus 4 is 1. I have 2x, I have a negative 3x squared and a plus 2x squared. So they're both like terms, so I just add coefficients. Negative 3 plus 2 is a negative 1 of these x squares. Where did I get 2x squared? From the question? That's part of the question. The question said, add x to the fourth minus 3x squared plus 5 to the polynomial 2x squared minus 4. So it was part of the question. Okay, let me do problem number 52. Okay, so let's do problem 52. Negative 4 a squared minus 5ab plus 2a squared plus 6ab minus 2b. Okay, so let's add these. I guess since they wrote it out just one next to each other, I'll just do that. So this is another way of doing it where you don't write one underneath the other, you just put one next to each other. And so let's do this. So I have here a squared term and another a squared terms. So these a squared terms are alike, so let's add these up. Negative 4a squared plus 2a squared is negative 2a squared. Next, I have 5ab and 6ab. So those are like terms, so let's add those up. Negative 5ab plus 6ab is 1ab. And then lastly, I have minus 2b. And that is your answer. So if I add these up, I get negative 2a squared plus ab minus 2b. Notice that none of these three terms are like terms. Therefore, I cannot add them and cannot combine these because they're not like terms. And so I've simplified it as much as possible. Let me do problem number 64. 3 y cubed plus y squared plus 1 plus negative 4 y cubed minus 6y minus 3. Okay, so let's combine like terms. I have a 3y cubed and a minus 4y cubed. And so if I combine them, I get 3y cubed minus 4y cubed is minus 1y cubed. Next, I have y squared, and that's the only term, so plus y squared. Next, I have minus 6y, and that's the only term, so minus 6y. And then lastly, I have plus 1 minus 3. So 1 minus 3 is minus 2. And I have added both of these polynomials. Notice that when I add, I usually add in descending order. It makes it easier so I don't forget any term. Let me do problem number 68. So for problem 68, it says subtract negative 6y to the 4 minus 5y cubed plus 9 from 2y to the 4th minus 7y cubed plus 8. Okay, so I want to subtract 6y to the 4th minus 5y cubed plus 9 from, so that's why I have the minus in front, 2y to the 4th minus 7y cubed plus 8. So I want to subtract negative 6x to the 4, negative 6y to the 4th minus 5y cubed plus 9 from 2y to the 4th minus 7y cubed plus 8. So first off, let me get rid of all the parentheses. And so I have 2y4 minus 7y3 plus 8. Minus and minus become a plus 6y to the 4th. Minus and minus makes it a plus 5y cubed minus 9. Let's combine like terms. And so I have here 2y to the 4th plus 6y to the 4th is 8y to the 4th minus 7y cubed plus 5y cubed is minus 2y cubed. And then lastly, 8 minus 9 is a negative 1. Let me do problem number 78. So I want to subtract these. So in exercises 76 through 90, perform the indicated subtraction. And so I have here negative 10t squared minus 6t minus 5 minus 10t cubed minus 5t minus 5. Okay, so let me subtract these. And so let me get rid of the parentheses first. So I have here a minus 10t squared minus 6t minus 5. Next, I have a minus sign outside the parentheses. So let me change all the signs inside the parentheses. So I have minus 10t cubed. Minus and minus become a plus 5t. Minus and a minus become plus 5. Oh, wait. That was 10t cubed. And so the largest term here is a negative 10t cubed. Next, I have a minus t squared. And then I have 5t minus 6t is minus t. And I have 5 minus 5, which cancels. And that is your answer. Wait. Yeah, 5 minus 5, which cancels. Let me do problem number 90. Negative 8u plus 11 minus a negative 2u to the fourth minus u cubed minus 12u. Again, let's get rid of the parentheses. And so I have negative 8u plus 11. I have a minus sign outside the parentheses, so I'll change all the signs inside the parentheses. So the negative 2u to the fourth becomes a plus 2u to the fourth. The negative u cubed becomes plus u cubed. The negative 12u becomes plus 12u. Let's combine like terms. And so let's find the leading order coefficient, the leading order term, which is 2u to the fourth. The next term is u cubed. I have 12u minus 8u, which is 4u. And then I have plus 11. And that is your answer. Let me do problem 94. In problem 94, it says, find the perimeter of a right triangle having sides as given in the figure. Okay, so we have the following. X cubed plus x, x to the fourth plus x minus 1, and x squared plus 2. So I want to find the perimeter. To find the perimeter, I'll just add all the sides, all the lengths. Of the sides. So let me do that. And so I'll just do x to the fourth plus x minus 1. I'll add to that x cubed plus x. I'll add to that x squared plus 2. So let's add these. Let me get rid of all the parentheses. So x to the fourth plus x minus 1 plus x cubed plus x squared plus 2. The highest term is x to the fourth. Next is x cubed. Next is x squared. I have x plus another x, so that gives me 2x. I have 2 minus 1, so that gives me 1. And that is the perimeter of this particular triangle. So that finishes off section 5.2. let me go on to section 5.3. Actually, let me so section 5.3, oops.